Welcome. My name is Martin Knabenhans. Today I am going to present you the eBase 800XA integration. eBase is the total plant engineering tool we use in our electrical control and system engineering for mining and cement application, and it's fully integrated into ABB's system 800XA. We will perform the following engineering steps in this tool. First, we will import customer data such as motor and component list and signal list into the engineering base. The next step is to apply typical configurations in order to generate automatically wiring diagrams, cabling, component lists, and as well the configuration of the application software. Then we will complete the I/O panel, assigning I/O boards and doing the I/O allocation. And finally, we will export the application software into ABB System 800XA. We start with the first step, import of data. The import takes place from a consumer list, typically defined in Excel. In such a consumer list, we have information like tag name, description, assignment to process group, template for the software application like a direct online template, definition of the group startup, assignment to a CAD typical in order to produce the correct drawing, and information on the location of the motor, the location of the MCC starter, and electrical information such as power, voltage, current, and so on of the motor. By choosing the import tool. In the import tool, I have already configured here my load list. I define on how I will import it as load tag. I can configure a mapping, which is already configured here. And as the last step, I will import the data. When I'm in the importing view, I can verify the data, and the verification process tells me that all these motors are not yet in engineering base, they are new. So I will design to import those data. I can exit here, and we can see here that in my diagram, group number 1, I have added 3 additional motors. If my customer is coming with a new revision of the motor list, I can repeat that step. We select again 800XA import and update items, and this time we will select a revision of that list. So I select here data source, and I'm selecting here the revision A of that load list, and I open it. I will load it into the system. I press verify again. Now we can see that 1 motor is new and 2 existing motors get some update in data. It shows me as well which information is updated. In this case, the comment is updated, and I can see here that the update is from oil pump to belt conveyor 1. If I check here this update, it's changed from reversible direct online to direct online. All this information on what is updated is stored as well in a log file, which can be later on used for the verification process. Then I choose what to import. I will import new and update. I will import the data. I can see here my motor number 4, which was added. We can verify again, and we can see that all information matches. So the import and update item tools allows us to import new data into the system and to change existing data by a managed compare process. If we look at the important data, we can click on each and every item, we can open it, and we can see in the dialog all the information that has been imported. The information can as well be viewed in a list format by opening a worksheet. So we can right-click on a group level, open a worksheet showing us all the load tags in a list format. So I can see here all my imported motors, and I can edit those data. Those worksheets, they work in principle like Excel within the database. As you can see, below the motor there is currently no information available, and we have as well no loop diagrams, loop drawings available. So the next step is to apply typicals to populate signals for each and every motor and to generate the drawings. I do this by going on the application level. I use a function which is called typical copy. I decide where my drawings should go to, into loop drawings, and I start the typical copy process. The system tells me what typicals will be created. We can see here for belt conveyor 1, it will create a direct online motor starter, and it will create as well a drift and a rope switch instrumentation. And it's doing that for all the motors. So we press OK. And now drawings will be created, and you can see here belt conveyor 1 already got its signals. So a lot of information is now added into the database. This information is basically all the electrical components required for the functions. This is I/O signals, this is cables, this is wiring, this is local isolator boxes, the motor itself, local start, stop, push buttons, and so on and so forth. The time it takes is about 5 to 10 seconds per motor to create all this information. So now this process is finished, and the first thing we're looking at is that we will look at the motors. We can see here in every motor we got the signal created, but we get as well all the devices created here, like terminals, switches that are required. All these devices are located on the drawings. I can open now the newly created drawing. And we can see here the drawing. The drawing updates. Let's just make that smaller first so we can see an overview of the drawing. We can see here the motor starter, the cabling, the local isolator box, the motor itself, and the wiring into the I/O panel. All the information is taken over from my Excel sheet into the drawing, such as the name of the motor control cubicle, the size of the motor, like 15 kilowatt, and all the signals are placed, but currently the signals are not allocated. You can see all the signals are not yet allocated to an I/O channel. After this step of creating all the drawings, we get all the signals available. The next step would be that we allocate them into the I/O panel. For this, I will close that drawing, and I will open another drawing. It's the I/O panel drawing, where I go into the layout of the I/O cabinet. I open the I/O cabinet layout, where we have already a prepared Profibus station, and on that Profibus station we will add now I/O boards. So I select here macro called insert I/O board. I can choose from a range of I/O boards defined in the project. For example, a digital input I/O board. I will place that. Another digital input I/O board and a digital output board. So I've made my I/O panel with the additional I/O boards that I need for my motors just created. I then close the drawing again, and I'm choosing my application, and I select the function which is called I/O allocation. The I/O allocation function allows me to see on one side all the signals, and on the other side I can choose the I/O panel where I would like to allocate those signals. So choosing the I/Os, choosing the field bus station, and in that station I can see here my I/O board number 1. Then I can just drag and drop my I/O signals to the I/O channels. From the wiring I have all the information on the wiring, so I can basically choose all the signals which are in the same cable and allocate them. Once they are allocated, they disappear from the list. Of course, I have to make sure that digital inputs and digital outputs are not mixed. If I would do so, the system would give me an error message. I selected the second board. I again select the digital inputs, allocate them. Some more digital inputs to allocate. Then I go for the DOs and I select the digital outputs to be allocated. Okay, once again. And let's see if there is some free space here for this digital inputs. Yes. We can allocate those as well. I can close this function. Once I've done that, I can open a various report. For example, on this I/O board, I can open a worksheet that shows me all the I/O boards. And I can see the I/O boards and the number of allocated signals in a board in a summary. It's one option for a worksheet. I can open other worksheets that allows me to show here the signals I/O allocation. So I can see here the complete I/O allocation of all the signals, and I can see here in which I/O channel and I/O board they are allocated. All these worksheets can be exported into Excel as well. Now that my eBase application is finished, I can export the functionality into Control Builder of System 800XA. By this, all the control software for that application will be created. So I've predefined here a diagram. I got a group. The group has 2 pre-selection for the routing, and I have some belt conveyors in there. I got as well all the hardware, such as the Profibus. The first thing is that I will export the hardware, selecting here 800XA hardware export. And by doing so, I can choose first the project. It shows me the process controller in that project, and I can export that process controller. You see at the moment there is no Profibus hardware in that controller. While doing that, first the system will check whether the structure is correct, and then it will start here adding in the control builder M all the required hardware. This includes not only the hardware. See here the Profibus station was created. Under the Profibus station has created the Fieldbus station. Under the Fieldbus station it starts creating the I/O board, and it will as well do the allocation and the configuration of the I/O channel, such as range min, range max of analog signal channels and so on. So this process is finished. We can close this. If we look at the I/O board, we can look at the I/O board editor in 800XA. We can see that all the variables have been created and assigned to the I/O channel in the way we have made the I/O allocation just before. Then we do the same for the application. So we export the software application. The system shows me here what I have chosen to export, so it's my group, and I will export that. You can see there is an application 1, but currently no diagram and no group existing. I export this application into System 800XA, and all my software blocks will be created, and as well the logic defined in eBase in the templates will be created in the control builder. So we wait for this to be complete. Okay, this process is finished. First we look at the diagrams. We can open the diagram here. We can see here our pre-selection modules. We can see here the group module. The group module is connecting to the motors. The motor page, we can see the control module for the motor, and we can see the different digital input signals, such as drift and rope switch in this case. Close this view. Then we are ready to download and go online with the project. Right click, open the faceplate for the group. So in the HMI application all the faceplates have been created. You can see the group faceplate, the group is offline. You can select here a group status viewer which was automatically creating, so we can see all the group, all the motors. We can show the pre-selection information. You can see currently no selection is made. We can change the pre-selection here, selecting to operate in direction of silo number 2. By this, 2 other motors get selected. We can then start the group. You can see the starting process, how the individual objects are started. So a complete group sequence was created in eBase and downloaded by a simple Excel import. We can as well look at the individual motors. And on the individual motors we can look at the configuration of the interlocks. And here we can see our rope and drift switches. If there is a problem with a rope and drift switch, we can simulate that here. We open the faceplate for it, and we just simulate that signal to be not okay. And we can see the motor is stopped, and the group indicates me that the group is not fully running. So basically complete parameterized software was downloaded from eBase into the DCS system. But I can also navigate from the faceplate back into eBase. If there is a problem with this rope switch, I can click in the DCS application, Open Drawing. And by this, in eBase, the correct drawing will be opened, basically we can see here our drift switch and the wiring information by the drift switch. So you have seen a complete integrated electrical and software engineering in one common tool environment. Thank you for listening and goodbye.